Hello everyone, my name is İlhan. I'm a second year physics student at Bilkent University, and today I will be presenting my project for the PHYS211 course. The project focuses on constructing and studying the Crookes radiometer, a fascinating device that demonstrates the interplay between light, heat, and molecular dynamics in a low-pressure environment. This presentation will cover a brief historical background of the Crookes radiometer, the purpose of the experiment and methodology of the experiment, its results, and finally conclusions. Let's talk about the historical background of the Crookes radiometer briefly. The Crookes radiometer, invented by Sir William Crookes in 1873, consists of a rotor with vanes that alternate between dark and reflective surfaces. When exposed to light, the vanes starts to rotate, which was initially attributed to radiation pressure by scientists like James Clerk Maxwell. However, later experiments by Arthur Schuster and Pyotr Lebedev disproved this explanation, showing the rotation was influenced by gas dynamics in a low-pressure environment. The breakthrough came with Osborne-Reynolds' theory of thermal transpiration, which suggests that temperature differences between the dark and reflective surfaces create a pressure gradient, driving the vane's motion. Today, the Crookes radiometer remains a tool for exploring rarefied gas dynamics. Now, I want to talk about our project and experiment. So let's start with the purpose of our experiment. What's the purpose of our experiment? The primary aim of this experiment was to build a Crookes radiometer and investigate the effect of temperature gradients on the rotation speeds of its vanes by understanding the forces at play, which are the thermal creep and drag force. We sought to measure angular velocities and temperature between both sides of the vanes and validate theoretical predictions. Now that we talk about what the experiment aims to do, let's move on to the experiment itself. First of all, I want to show you what equipment we use. Here is a list of the equipment we used. Now, I want to talk about the methodology that we applied. First, we start to design our radiometer. Vanes were created using 0.1 mm thick paper with one side painted black and the other covered in reflective aluminum foil. These vanes were mounted equidistantly on a lightweight rotor inside a sealed glass jar to minimize friction. A needle was used as the pivot to reduce rotational resistance. Then, a vacuum pump was connected to the jar to create a low-pressure environment. The lid had holes for a vacuum pipe and thermocouples, which were sealed with silicone to prevent air leakage. Then, thermocouples were positioned to measure temperature differences between the black and reflective sides of the vanes. This data was used to calculate temperature gradients. A 25-watt light source illuminated the vanes, and a tachometer measured their angular velocity. Different light intensities were tested to analyze the relationship between temperature gradients on rotation. Unfortunately, the experiment did not yield consistent results. While some initial observations, such as momentary vane rotation, were recorded, these were later attributed to airflow caused by the vacuum pump rather than the intended thermal effects. The second experimental setup showed the most promise, with slight vibrations and a full rotation observed under light exposure. However, these results could not be replicated due to issues like misaligned vanes and damage to the reflective surfaces. The primary source of error was the inadequate vacuum level. Literature suggests optimal pressures between 0.1 and 3 Pascal for effective operation, but our pump could not achieve such low pressures. This limitation significantly impacted the radiometer's performance. In conclusion, despite the challenges, this project provided valuable insights into the complexity of constructing and operating a Crookes radiometer. The experiment highlighted the critical role of vacuum level and precision in design for studying molecular dynamics in rarefied gas environment. Although the results were inconclusive, the experience emphasized the iterative nature of scientific inquiry and the importance of addressing limitations systematically. Thank you for your attention, and I hope this presentation has shed light on both the challenges and the scientific intrigue of the Crookes radiometer.